questions. One is, I'm curious about beyond the 2 megawatt reactor, how long it would take to go commercial. Even for a 2 megawatt reactor, that was one of my questions. In the abstract, it was 2035 or 2030, and I'm wondering why you have, in the abstract, you have 20 years between the success of this R&D reactor on the one hand and actually commercializing it on the other hand. That was the first question. The second question is it was a little unclear to me because you're doing 2 different reactors. They're really quite different. Yeah. But on the MSR version, what are the thoughts about using one train of fuel mixed in, the protactinium mixed in with the fuel, or separating it out till it decays into uranium-233? What are the thoughts on that? This is a debate in the United States on the same question. Which is the best way to go?
Okay. For the first question, because our plan is to build a 2 megawatt first, then we're going to build a 10, 20, or 30 megawatts reactor. Then we go to 100 megawatt or 200. So we have to do that step by step. So to build several reactors before we actually build a large size one. So that would take us like 20 or 30 years. And also, those 2035, 2040 are only the years we put in our proposal. So it's not a fixed schedule when we're going to commercialize it. It's just our, yes. And for the second question, for the molten salt cooled reactor pebble bed one, we're thinking that we put several thorium pebbles inside and doing some experiments. So basically to get some data, not seriously produce any uranium-233, maybe in the future, but not for the 2 megawatt one. And for the liquid fueled molten salt reactor, we're seriously thinking doing the conversion from thorium to uranium-233. So yes, there are two ways to do that. You can just remove the fuel from the core and sit there for like 30 or 60 days. So we're also evaluating that. We haven't made our mind which way to go. Yes.
So 2015 for criticality for the molten salt fuel reactor is a very aggressive timeline.
That's correct.
You mentioned very briefly a number of the technical challenges that need to be met in that time period. What do you do as kind of the biggest challenges or obstacles to overcome to meet that aggressive time schedule?
You asked me which one is the...
What are the top priorities, the biggest concerns in order to meet that aggressive time schedule?
The biggest concern is overall the material.
Is that the vessel material, the heat exchangers,
both? Yes.
It's my understanding that you're going to be using lithium-7 enriched salt, molten salt. Are you working on facilities to produce that? To my understanding, there are no facilities in the world to produce, the lithium-7 enriched.
There's some facilities in China that produce it. It's not a very large-scale facility. It doesn't produce a lot, but we're persuading them to increase their production. So we'll see where it goes. So. And those enriched lithium-7 are not highly enriched. It's probably only 99.95.
Okay.
Are you planning to get further enrichment than that, or are you planning on just living with that?
It's ideal to have a high enriched lithium-7.
Yes.
But it does not depend on us. It depends on the company. So how much money we
Is it the mercury process?
I'm sorry?
Is it the mercury process or something?
Yes. They also have new techniques, but it's in lab scale. Yes.
What kind of fissile material do you expect to start up these molten salt reactors? For the 2 megawatt and then the 10 megawatt?
235.
And is that, what's the enrichment you would expect?
10%.
10%?
Is that true for both the cooled and the fueled reactor, or just the cooled one?
Just the cool.
What are you planning to use for the fueled one?
That we haven't decided.
Are you collaborating with any of the other countries that have done research on molten salt, like France and Japan?
We talked with them at some point. We also talked to Russians, and we're still working on how to work with them. So there's no real steps there, but it will be some real collaboration maybe next year. So. Yes.
Well, if you need any U-233 to start up the molten salt reactor, we have some that you can talk to DOE friends about. Because we're planning to waste $500 million on destroying it, so you might want to talk to them before they get that contractor wasting more of our taxpayer dollars. What is the relationship of your Tsinghua HTR pebble reactor to the German one? I thought that was given to China some years back.
Yes, that was what I heard. I was not involved in the high temperature reactor project, so I don't know exactly what the relationship. But that what I heard was I think that the same as you said.
Okay.
Yes.
You have you selected a designer? Is there one person who is the designer for the 2 megawatt molten salt reactor, the traditional molten salt reactor, or is it a team that's working on the design?
It's a team.
On the turbine, what crushed the South African PBMR was the R&D that went into trying to develop a closed cycle gas reactor, Brayton cycle reactor. Who's doing that research? Is that part of your institute, or is
No,
it?
it's not a part of our institute. It's part of the Academy of Sciences. It's a different institute. They're located in Shanghai. They're actually developing that for coal-powered
Co-generated.
reactor. Yes, the power plant. Yes.
What salt were you using for your intermediate loop?
Trinec.
Trinec, and is it the same for the buffer salt?
Yes, that's right. Yes.
You mentioned you might be running thorium fuel. Do you have?
You mean the water reactor?
No, in the pebble.
In the pebble reactor, yeah.
Where will you be getting the thorium?
We have institute that is able to make several thorium pebble fuel in their lab. So we're not sure about the quality of the fuel, but they are able to make several. So we can at least do some experiment. We were talking with the a manufacturer. We produce the regular pebble fuel for Tsinghua University, and they have some difficulties working on solid.
And what scale are they working on?
You mean for the regular pebble fuel?
For the uranium?
We're using that large scale. That's for I think it's for a 200 megawatt demonstration gas cooled reactor, so it's large scale. Compared to them, our 2 megawatt only use a few of their pebbles.
I think we have time for one more question, and you're able to hang around a little bit afterwards if people want to ask some more questions afterwards. So first,
Yes.
I'm curious about the structure of the project from a funding perspective. You have about $70 million a year. I assume the spend is more or less flat over the 5-year project.
We spend the money based on the budget that we proposed. So when we write proposal, we have planned to spend a certain amount of money for each year.
So that works out to roughly 1,000 people involved, you know, $70 million a year buys about 1,000, you know, skilled technical people in China, right?
In our institutes, there are currently about 300 people working full time on it. There are about another 100 people from our outside to work on it, so it totals about 400 people.
Is that calculated based on just converting the yuan to dollars? Is that the way you come out with 350 million?
Yes, that's US dollars. That's converted to,
Just a conversion.
yeah.
And that buys more in China than it would here, I suppose.
Not necessarily. The tax is high. Because you have to pay the tax.
No, okay.
4 degrees.
All right, why don't we go ahead and thank our speaker.